So this is a rather short lecture which is just continuing from where we left in lecture 1 for week 2. This is just going to discuss a little bit more about the pseudocode that we saw. So the first thing that you have to understand is there is a concept of variables and constants, right? Just like you probably would have studied in mathematics, variables and constants. There are variables and constants in pseudocode as well. So let's just take example of this same equation, x square plus 2x minus 15 equal to 0. So now the question is, how many variables are there, right? Now from what you have been conditioned in mathematics, you would tell me that this has only one variable, and that variable is x, right? This is what you guys have studied. This is why it is called quadratic equation in one variable, because there's just one variable, and that is x. But this is in mathematics, right? When we discussed that algorithm, right, the algorithm where we said that you know there are essentially three coefficients a, b, and c, and then we are going to find two of the roots. So essentially, when we talked about algorithms, right, we were only talking about these three coefficients and these two roots, right? So what we expected really was that the user of our program, okay, program, algorithm, whatever you call them, um, the user of our program is going to provide us some values, right? What these values will be: a, b, and c, the three coefficients in the quadratic equation. Now in return, what are we going to do? We are going to solve the equation x square plus 2x minus 15 means a equal to 1, b equal to 2, c equal to minus 15, and then we will basically find the two roots for this particular equation. We saw, I think the roots were, if I'm not wrong, minus 5 and 3, right? Yeah. So we'll actually return two more values, but these two themselves are really variables in some sense, right? Their values will vary, and what will they vary upon? The values of a, b, and c. And by the way, from here onwards, right, we are just going to assume that the only case of a, b, and c, the only equations that our user is going to provide us to solve are those which will have real values, real roots. Okay, so we don't really have to write any if statements. You remember we wrote those if statements. We don't really need to look about those statements anymore. So what really happens is, now I've just shaded this area, so this, it means that this is no longer a part of our algorithm. So essentially we calculate the discriminant, and then we straight away move on to find the roots. Yeah, and another thing that here I had written a different case for d equal to 0 previously, because we were saying that in this case there's just one root. Now I'm saying I really don't need to handle even that separately. What will really happen is that if d is 0, then both these terms will evaluate to the same value. So it is just a special case where the roots will evaluate to the same value. So now the question is, in this algorithm that we wrote, right? This is we continued and then wrote a pseudocode for it. In this algorithm, what exactly are the variables, right? So a, b, and c, these are the things that are going to vary, right? I mean, the user is going to provide us different values for this, and based on that, we are going to calculate the roots. The roots, we call them as x1 and x2. This is when we actually converted the algorithm into pseudocode. We chose two names for these roots, x1 and x2. So these values will be computed by us, but even they will vary from uh, one equation to another equation. Okay, so, and they will of course be calculated with the help of a, b, and c. So now the idea is that even though in the world of mathematics, this is basically an equation with just one variable, when we are going to convert this into an algorithm and then into a pseudocode, and then finally write a program for it, the number of variables that we are going to have are essentially these three, a, b, and c, and these two, x1 and x2. X1 and x2 are the variables for which values are to be computed by us, and a, b and c are three variables whose values will be provided to us by user. And similarly, what is the other thing that we have studied in mathematics? The constants, right? So we say that here you would say that this is probably a constant, 2 is probably a constant, and this one which is not shown here is another constant, right? So in terms of mathematics, we say these are the constant values which are associated with this equation, where variable is x. But again, let's just come back to our realm, the realm of algorithms and pseudocode and programs. And all these have now become variables, as I said, right? Because these are the things that user will give us, the user of our algorithm, the user of our pseudocode, the user of our program is going to provide us, and their values may change. So now you have to understand that when you solve the equation, you essentially solve one particular equation, right? This is the particular equation you solve, but now you are changing it into something that can solve basically any quadratic equation, right? And this is why what I am saying, that now the variables and constants are changing, right? You are doing something that is higher than solving one particular quadratic equation. You are now moving into an arena where you are basically writing some instructions which can find roots for any quadratic equation. Okay, so now this is why it might seem a bit awkward. It may not be intuitive to see that whatever used to be our constants in mathematics are now becoming variables. But this is the idea here, that what exactly am I going to need? I'm just going to need the coefficients associated uh, with the ax square plus bx plus c form of polynomial. So no, but that doesn't mean that there are no constants in the world of programming. Okay, there are still some constants. So for example, if you write something like b square, the power, right, the power of b is essentially still a constant. Okay, this is also a constant in the world of programming. Similarly, when you calculate 4ac, 4 is still a constant, or wherever you calculate 2a, 2 is still a constant. So now the question is exactly what is a constant, and what exactly is a variable. Now there is like one simple way. It cannot tell you every time, but I think most of the time you should be able to figure out. So variables are basically those. So when you are writing your algorithm, variables are those symbols, let us call them for now, those symbols which can appear on the LHS of an assignment step, right? So assignment step is something where you are writing something like something equals something else. So in here, the part on the left side of a variable, of the equal to sign, is a variable, and constants are those who will always appear. And this is the difference. Here it is can, and here it is must. So what can means is variables can appear both on LHS as well as RHS of an assignment statement, whereas constants can only appear on the right hand side of your assignment statements. So maybe this is probably easier. You first identify the constants, and then whatever is left is they are going to become variables in your programs and your pseudocode, right? So and remember one very basic difference between mathematics and programming. In mathematics, x equal to 5, whether you write x equal to 5 or 5 equal to x, they are essentially the same, right? A mathematician will probably understand both of them and will not have a problem. But computers, okay, especially when you are doing programming, these two statements are not the same. Okay, so in most of the cases, all the programming languages that I have used till now, this is actually an invalid statement. Okay, there cannot be a constant on the left hand side of your equal to. Okay, whenever you are saying that x is going to get the value 5, this is exactly how you write it: x equal to 5, and not 5 equal to x. So this is a change that you have to inculcate from the world of mathematics. And let us just go back to the same pseudocode that we have been seeing for a while now. Now if I just want to say what are the variables here, so I'd say A, B, and C are the variables. Now you can understand that even though A, B, and C are not really appearing in this code, right? I mean, in this pseudocode, you cannot see that A, B, C are appearing on anywhere on the left hand side of of an equal to statement, right? But you have to understand that basically what is happening is my user is going to give me three values, right? So in some way, like, just assume that above these instructions there are three more instructions here which say a equal to 1, uh, b equal to, whatever it was, b equal to 2, and c equal to minus 15. So essentially there are three statements. Those three statements are implicit as in, these values will be somehow assigned to a, b, and c. I have not shown how they will be assigned, and when we start doing programming, this will become much more clearer that this a, b, and c will also be present somewhere where you will be giving them values, so they will be appearing on the LHS of an equal to statement, an assignment statement. And similarly D, it's quite clear, right? It is going to hold a value which is going to come from the discriminant calculator procedure. Similarly, x1 and x2 are going to get some value which is being evaluated from here. And similarly, the constants here, you can already see 0 is a constant, 2 is a constant, again this 0, this 2, this 2, these are all constants, right? By the way, don't get confused with 1 and 2 that is there in the x1 and x2. So these are just name of the variables. I could have actually named them xa and xb, or xp and xq. Okay, so these are just the names. Okay, so these 1 and 2s are not really constants. They are a part of the name of a variable, right? So don't get confused here. Now in the pseudocode that we have just seen, there is a procedure called discriminant calculator, right? So essentially what I'm saying here is, um, somehow this procedure is able to create this procedure is able to calculate b square minus 4ac. I really don't care how, but as long as I trust that this procedure is correctly implemented, correctly defined, I can say that okay, I will get the value of d here, and then I can proceed with my checks and calculation of the roots, so on and so forth. So essentially what I'm trying to say is, sometimes, right, you will actually just trust someone else. You will say that there is an existing procedure, and I even if I do not know what is exactly written inside that procedure, I trust the person who wrote it, right? So just like I didn't tell you, I didn't show you the exact code of discriminant calculator. Actually, I did show it to you in the last lecture, but not in this one. But right, I mean, you can basically understand that yeah, discriminant calculator will correctly calculate the discriminant. So these kind of scenarios, when you start programming, you will actually come across many times, right? So you are going to use code that was written by someone else, not you, right? So almost all programming languages have certain procedures that you can simply use in your code. You don't actually have to provide the details of how that particular thing is done. You can simply use that code in your own code as well. Okay. um, so 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 what, a very good example of such kind of such a scenario where you might still require where you might actually be happy if you get some code or some procedure written by someone else, is in the case of where you are trying to find the square root of t, right? So nobody really would like to explain the process of finding square roots. So it would probably, you will also find your life easier if someone else has already written that procedure for you, so that you can find the square root of t. So these kind of procedures are also known as library functions. Okay, so library functions, because essentially what happens is, whenever you start using any particular language, almost all languages have certain libraries. Now the term library, you can understand it is similar to the term library that we are already aware of. So what exactly does a library contain? A library contains different types of books. So in computer science, when I call library, essentially it is a collection of different types of procedures, okay, different types of functions, let's call them. And these procedures, by the way, I'm currently just interchanging the terms functions and procedures, so don't get confused, right? Whenever I say function, I really mean procedures, and vice versa. So what we, most of the programming languages, they have some inherent functions, okay, some inherent procedures that are shipped along with the language itself, that the compiler of the language, for example. Okay, we'll come to know what compilers are in probably the next lecture, but for now just assume that whatever software is there that is going to help you in writing the programs, it also comes up with certain pre-written codes, okay, and these pre-written codes are also known as library functions. Typically the bare minimum that people use from those library functions are functions to take inputs from the user and send them the outputs. Another common use case where you would probably like to use a library function is for mathematical operations like square root, right? The square root is a very good example. So if I have a library function that can calculate square root for me, probably I would like to simply use it rather than writing it myself. So, and this is you have to understand, you are not forced to use the library functions. You can of course write these functions, these procedures on your own as well, but as I said, right, once you start coding, once you start programming, you'll realize it's much more easier to simply use a code, a piece of code or a procedure that was written by someone trustworthy, like the people who created that language, rather than attempting to write it on your own. So this was a small lecture. Again, I'm not going to talk about your homework. Just wait for the next lecture. In the next lecture, we are actually now going to look at some actual code. Okay, thank you guys.